Hi everyone, today we'll take a look at composite functions. So I'm sure you've come across composite functions in your earlier, maybe 9th grade or 10th grade. So nothing much changes from there when I talk about composite functions in IB Math. Yes, the functions can get a little bit more complicated, can get a little bit more hairy, but at the end of the day, the concept and the approach of solving any question remains the same. All right, so I've just drawn a visual really quickly here. So let's say you have a function f of x, let's say you have a function g of x, and you take in an input called x naught for f of x. So the output is f of x naught, right? When you put that as your input for g of x, you get what is called the composite function g of f of x, or oftentimes they write it as g o f of x naught. That's also quite common. This O is kind of like the parentheses which represents composite functions. All right. Now let's take a very simple example. Let's say I have f of x is equal to x squared. Okay. And let's say my g of x is 2x minus 3. Now I've taken really simple examples here. Where the domain and the range has no restriction, okay? So later on, we'll take a look at a few examples where the domain and the range is restricted, which essentially makes the question a little bit more tricky. But again, if your concepts of absolute functions or exponential functions or radical functions or reciprocal functions, log functions, if they're all clear, right? If there's no confusion in them, solving them shouldn't be much of a problem. It's just the understanding of how the function behaves is the key. For such unrestricted functions, which have no sort of restriction on them, they're super simple to solve, right? So let's say I have, just a quick revision. The range of f of x is the domain of g of x. So I'll just write it here. The range of f of x becomes the domain of g of x. That's the key point here, okay? That's the key to remember, okay? So let's say I have g of x, which is 2x minus 3, all right? So my g of f of x would literally translate to 2 times f of x minus 3. That's it. Now I know my f of x is x squared. So all I have to do is I just have to substitute it in. So I'll have g of f of x is equal to 2 times x squared minus 3. That's it. That's literally it. And you can verify. You can maybe take x is equal to negative 2. Well, your x squared would then be 4, which is your f of x. Then if you want to put in g of x, you'll have 2 times 4, which is 8. 8 minus 3 is 5. So essentially g of x, when x is equal to 4, if f of x is equal to 4, then x is equal to minus 2. So you can essentially write it as g of f of x, where, let me erase the x and I'll just put a negative 2. So let's put a negative 2 here. Negative 2 is equal to 5. That's it. That's pretty simple, right? Okay, let's move forward. Okay, so composite function mapping. This is just another visual that I have. So I just want to show, like, let's say you have a function f here, let's say you have a function g here, right? For an input x, it goes into f of x, and then you put it in g function, and it's going to be g of f of x. Or another way of writing g o f, right? Or you could, if it was f o g, you could just call it fog, right? Simple. So if you want, I can just write the notations here just for clarity. I can write this f of g of x can be written as f o g of x, like this. Or if you have f of x, that's also very much possible. We can have f of x, and finally g of x, that would be written as g of gx. That's about it. Okay, let's look at a quick example, right? Very simple, no restrictions. You can see in the question, you have f of x is x squared plus 3x plus 1, and g of x is 2x minus 3. Okay, so we just have to find f of g and g of f, right? Two composite functions. Okay, so let's get started with the first case, right? I'll put it in blue. So my f of g translates to f of g of x, which basically means I'll have g of x for wherever there's x squared, x in my f of x, right? So I have g of x whole squared plus 3 times of g of x, and I'll have plus 1, right? Pretty simple, nothing too complicated. Let's keep going. Okay, now wherever there is g of x, I'm going to replace it with 2x plus 3. So I'll have 2x minus 3. 2x minus 3 whole squared plus 3 times 2x minus 3 plus 1. Okay, super simple. Let's keep moving forward. We'll have 4x squared. 3 times 2 is 6. 6 times 2 is 12. So minus 12x plus 9 plus 6x minus 9 plus 1. So the plus 9 and the negative 9 cancel out. We're left with 4x squared minus 12x plus 1, right? Or have I missed something? Oh yes, I have missed something, my bad. Yes, so this would be minus 6x, not minus 12x. So we have minus 6x plus 1. So that's my f of g of x. Again, pretty simple, nothing too complicated. Let's go to the next page and we can do the second part here. We have g of f of x now, right? So what does that mean? G of f of x. Okay, all I have to do is I just have to put in wherever there's x, I'll just put f of x. So I'll have 2 times f of x minus 3. That's it. All right, next 2 times I'll have x squared plus 3x plus 1, right? X squared plus 3x plus 1. Okay, perfect. Minus 3. All right, just expand it. What do I get? 2x squared times 2 times 3, 6. 6x times 2 minus 3 minus 1. That's it. Simple. Simple game, nothing too complicated. Let's move forward to the next question. We have f of x is equal to 3 minus x cubed raised to the power 1/3. And we have to find f of x. Okay, so what I'll do is I'll write each f of x as a different color, so it's just easy to visualize. Okay, so let's say we have f of x, so I'll just write it like this. I'll change the color to orange, and I'll write f of x like this. Okay, so let's go back to blue. I'm going to have 3 minus, okay, let's go back to orange, f of x whole cube, let's go back to blue, raised to the power 1/3. Okay, now my f of x is 3 minus x cubed raised to the power 1/3. Now, I'll just skip a step really quickly because I think everyone understands. If I have this to the power 1/3 and I cube it, well, the exponent kind of nullifies, right? And I'm left with raised to the power 1, which is just 3 minus x cubed to the power 1. Okay, so I'll just write it on the side really quickly. Take green. F of x whole cube is nothing but f of x 3 minus x cubed raised to the power 1/3, and then cubed again. So this and this cancels out as we multiply exponents. So we're just left with 3 minus x cubed. Okay. Now if I put it back in the original composite function, what do I have? I have 3 minus x cubed raised to the power 1/3. Again, 3 and 3 cancel out. I'm left with positive x cubed. Positive x cubed raised to the power 1/3 is just x itself. So my f of x is just x itself. Pretty simple. Again, yes, it got a little bit hairy. I hope it clears it up. You just have to make sure you just focus on the individual components and then slowly open them up. Okay, let's look at this question. This is a good question, I would say, in the sense that it will really make you think, okay? So what we have is we have two functions. Now our f of x is a piecewise function. Piecewise function, okay? So it has certain restrictions, although in its natural form, if you take a look at 1 plus x squared, it's just a parabola. There is no restriction on a domain, but in this question, they have restricted the domain for the parabola and x plus 1. That's the game here, okay? That's what you have to focus on. And here you have g of x, whose domain is also restricted, okay? Now remember, in f of g of x, I'll just write it down here. Range of g of x is the domain of f of x. That's the key to remember here. Don't miss this, okay? You cannot take this as the domain now. This is not your domain. This is your domain. You have to work with this and ensure that the range of g of x matches the domain of f of x. Okay, I'm going to repeat it again and again until it hits you, okay? If it hasn't, don't worry. We'll keep moving forward and eventually you will get it, okay? So here's what I'm going to do. There's two ways to go about it. I can put a direct substitution. Wherever there's x, I'll put g of x, and I can work with that. Or what I can do is I can find the range of g of x and then correspond that range to the domain that I'm given for f of x. Okay, I have two options. If you want, you can pause the video, try the question. Otherwise, I'll show one method and maybe you can try another method and correlate your answer. Okay, so what I'll do is I'll write f of x, or I'll write f of g of x as 1 plus f of x whole squared, okay? And I'll write f of x plus 1 like this, okay? And now my domain will be g of x less than 1, okay? Here it'll be 1 less than g of x less than or equal to 2. And then I'll have my domain of my original g of x, which is minus 2 less than or equal to x, which is less than or equal to 1. Okay? This is how it's going to be. Sorry. Okay. Now, nothing. I just put in g of x and expand it. So what do I have here? I have 1 minus x whole squared, right? 1 minus x whole squared. So if I expand this, I'll have f of g of x is equal to, I'll have 1 plus 1 plus x squared minus 2x. So I'll have x squared minus 2x plus 2. Okay, I'm just skipping a step. You can work it out on your own. All right, and then you have minus x plus 2. Okay, that's about it. Now, same thing. If I put in 1 minus x for g of x, what do I have? I'll have 1 cancel out. I'll have minus x is less than or equal to 0, or I can say x is greater than or equal to 0. Okay. Similarly, I'll have the inequality here as well. 1 is less than 1 minus x. I subtract 1 from both sides. I'll have 0, and I'll have a 1, but I'll have a minus x. So I have to switch the signs. So what will I have? I'll essentially have minus 1 less than x less than 0, less than equal to x and less than 0. Now, this has to match my domain for the original g of x. Remember, the range of g of x is the domain of f of x. Okay, got it? So this is 1 and this is the same as well. Okay, now what do I do? Now the game here is to take the intersection. Let me change the color. Take purple. Okay, you have to take the intersection. If you remember your sets and subsets, you have union and intersection. So you have to take the common range of values that suffice both of the constraints. So here we have all values greater than or equal to 0. Here we have any values between minus 2 and 1. So obviously the intersection, let me see if there's a new page. Okay, great. So obviously the intersection for the first constraint comes between 0 and 1, both included. You can check here, right? This can be anywhere from 0, and this can, at max, this can take a value of 1. So obviously the domain would be from 0 to 1 included. That's why 0 to 1 included. Similarly, for the second part, I have -1 to 0, and I have -2 to 1. So we can take this and this. As you can see, if you draw a number line, you'll have -2, -1, 0, and 1, right? Sorry, this is kind of going outside the page, but 1, right? And you can see that this is the first constraint, this is the second constraint, like this. Similarly, if I were to draw for this as well, what do I have? I'll have -2, 0, and 1. Well, this constraint would go all positive numbers, and this would be kind of constrained here, so I'm left with this region and this region. So for the domain for the second part, it would be -1 included all the way up to 0. And 0 is not included, okay? 0 is not included. So my second domain would be -1 to x to, sorry, I made a mistake, and to 0. To 0. So what do I have? I have x squared minus 2x plus 2, and I have minus x plus 2. So now my f of g of x basically comes out to these two functions, okay? That's my composite functions. Again, I'll just quickly go over this. Let me take the laser pointer. Okay, so I had g of x, I had f of x, I had f of x as a piecewise function, right? So the domain of my g of x will be the range of my f of x. So first, I had to substitute wherever there's x, I put in g of x, I expanded it. This was the domain for my f of x. However, if my domain for my g of x was not restricted, this would be perfectly fine. We would have x is greater than or equal to 0, and -1 is greater than less than or equal to x, which is less than 0, right? We could stop here. However, the domain of g of x is also restricted. Because it's restricted, we have to take the intersection. We have to take the common points that satisfy both constraints. That's the key, right? Otherwise, we would have been perfectly fine. We wouldn't have to worry. We would just take whatever is given and we would just move on, and that would be the question, right? Okay, perfect. So let's move on to the next question. Okay, so we have two modulus questions with restricted domains. Now this question can get quite hairy and intricate. In fact, you could even spend 20-25 minutes solving it. So if we use the approach that we used in the previous question where we broke it apart, found the intersection, we can do that. It'll just take really, really long time. So better method to do, what we can do is we can just find the range for both functions and then correlate it to the domain of the other functions, okay? So let's say I have f of g of x, okay? Before, we have to open the function for its corresponding, you can say corresponding restrictions, right? Hopefully you've taken a look at my modulus functions and you can understand that how we're going to open this up. So we can see at x equal to 2 and x equal to 0, we'll break these functions apart. So I'll have my f of x. Let's break it apart. We'll have -1 minus x minus 2. That should be minus x right here, minus x, -1 minus x plus 2. So it should be plus 1, okay? And the other one will be x plus, I think -3. Let me just check one more time. Or you know what I'll do? I'll just write it all together so that I don't make a mistake. Okay. So I'll just erase this. And I'll take the pen again, so I'll have minus x minus 2, and I'll have -1 plus x minus 2. This will be from 0 to x to 2, and this will be from 2 to x to 4. One small change, this is not inclusive of 2, and that's about it. Okay, so if I expand this, what do I have? I have -1 minus x, so I'll have minus x. This is a plus 2 now, so -1 plus 2 is basically 1, and then I have x right here, and this is -1 and -2, so this is a -3, right? So I have from x to 2, and you can just ignore this, x to 2 to 4, okay? This is my first function. Now, what about my g of x? I'll take orange. Okay, so my g of x would be 2 minus -x and 2 minus x itself. Okay, so this would be from -1 to x to 0. This would be from 0 to x to 3. Okay, that's about it. So if I I'll just clean it up here itself. So I'll have 2 plus x and 2 minus x itself. Okay, so let's go back to the pen. 2 plus x, 2 minus x, g of x. Okay. Now again, I can start putting my g of x inside the f of x and then create a more of a restriction domain, find the intersection, so and move on, so on and so forth, right? That's a fixed method. But let's think of it a little differently, okay? So if my domain is from -1 to 0 and from 0 to 3, what would be my range? So let's find the range. My range for this would be, well, I'll have my y, okay? If I take a 0, what do I have? I have a 2, and if I put a 3, what do I have? I have a -1. So it's essentially from -1 to 2, okay? So from -1 to 2, and what's my range going to be from here? Well, if I put a 0, I'm going to have 2, so I'll have 2, and if I put a -1, what do I have? I'll have perhaps 3. No, I'll have a -1, so it'll just be 1, okay? So it'll be -1 to 2 and -1 to 2. Sorry, 1 to 2 and -1 to 2. So that's going to be my range. Now let's look at this part, okay? Let's look at this part. So now the domain for this function is from 0 to 2, and this is 2 to 4. Well, if you look at both of the g of x's, neither of them have a range more than 2, right? Neither of them, they all stop at 2. So essentially, it won't even go into this function. It won't. It'll just go into 0 to 2 or -1 to 2. Okay, that's the game. So now if we move forward with just -x plus 1, what do we have? Well, we would have a domain of, or the range would be capped or restricted to, well, it would be restricted to essentially -1 to 2, like it's mentioned here. And for here, this would actually go to 0 to y to 2, right? That would be the intersection, right? I've just used simple observation. I haven't used any formula, none of that, okay? Right, so now what we do is we're just going to focus on this part, okay? And now we're going to correlate both of these piecewise functions to just -x plus 1, okay? So now we know that the domain for this function is perfect, right? It's the intersection anyways of this. So we just take, what we'll do is I'll take two cases here. So I'll just change the color again. I'll take purple. So if I take the first part, what do I have? Well, I'll have minus of minus. Well, I'll just write it again. Okay, so I'll have 2 plus x like this, and then plus 1, which is basically -2 minus x. So -2 plus 1 is -1. So -x minus 1. I'll just erase and write it down again. -x minus 1. -x minus 1. Okay, and the domain would be from -1 x to 0. Okay, similarly, this one would be this one would be minus of, well, I'll just write it here, minus of 2 minus x plus 1. That should be x minus 1, right? X -2. -2 plus 1 is -1, so x minus 1 from where? Now this is the range that's allowed, which is the domain for my f of x. So similarly, my I need to find the correct domain so that I get this range, right? So I need the range to be from 0 to 2. When do I get 0? When my x is when do I get 2? When my x is 0, and when do I get 0? When my x is 2. So now x 2 2. That's my composite function for f of g of x. So f of g of x comes out to be this right here. Yes, it was a little complicated, but I hope it was understandable. Let's try now doing g of x. Okay, so I'll just rewrite everything so then we can go ahead and start g of x as well. So now that I have everything ready, let's start. So same thing, we're gonna do the same thing. Now we're gonna take the range of f of x. Okay, so if we take the range of f of x, what do we have? Well, let's take a look really quickly. If I put a 0, I'm going to have a 1, okay? And if I put a 2, what am I going to have? A negative 1. So negative 1 to 1, okay? That makes sense, right? If I put a 0, I'll have a 1. If I put a 2, I'll have a negative 1. Okay, perfect. Similarly, if I put 2 here, I should have a 1, right? If I put a 2, I'm going to have a negative 1, okay? And if I put 4, I'm going to have a 1. Okay, so that's my range. Okay, that's my range. Okay, that's my range. Okay, now let's look at the domain, right? My domain is from negative 1 to 0, which both of them fit. That's good. Okay, and similarly here, it's from 0 to 3. Okay, 0 to 3. So this also fits. However, we're going to change up, restrict it a little bit more. So here, our intersection of these things would be negative 1 to y to 0. Okay, so that this should be the range for both my f of x's when I broke them apart. Similarly here, my range would be 0 to x all the way to, and this would actually just be 1, and this would be x equal to 1. Okay, so I'm going to have 3 different composite functions in this case, not 2 but 3. Okay, so let's start. Okay, so if we're going to have f of g, sorry, let me write it again. It's g of f of x. So just erase, and let's take g of f of x would be, well, for this part, this works with essentially both of them. Actually, so we have 4 cases. I'm sorry. We have 4 cases, so they work for both cases. So we'll have 2 plus negative x plus 1, 2 plus x minus 3. So this comes out to be negative x plus 3. This comes out to be x minus 1. Okay, so I'll just erase them and rewrite all over again. So minus x plus 3 and x minus 1. Minus x plus 3 and x minus 1. So minus x plus 3 and x minus 1. Okay, again, my domain would be this and my range would be this. Now, if this is my range, what would it correspond to this domain, right? If I want a domain, if this is the range, then my domain should be what? What should it be? Well, if I want a negative 1 here, right? If I want a negative 1, I'll bring it here. My x should be from 2, right? And if I want a 0, well, this should be just 1, right? Just 1. So from 1 to 2, okay? Now, similarly, if I want my range to be from negative 1 to 0, well, if I want a 0, I should take it to 3, right? I should take it to 3. Similarly, if I want it to be negative 1, what should I have? Well, I should have a 2 here. So 2 to 3. Simple. Nothing too crazy, okay? So this is half of it is done, another half to go. Okay, so now if I put it in this function, let's say 2 minus x plus 1 and 2 minus x minus 3, well, what do I have? I have 2 plus x minus 1, 2 minus x plus 3. Okay, so I'll have x plus 1 and minus x plus 5. Okay, minus x plus 5. Alright, so let me erase this, minus x plus 5 and x plus 1. Okay, so the pen, x plus 1 minus x plus 5. Right, this is also g of f of x. Alright, so now for this, for this part, for the first f of x, my range has to be from 0 to 1. Well, if I want 0, what do I put? I just put a 1 here. That's it. I just have to put a 1. Okay? And so that would be just 1 of x. If I wanted to go all the way to 1, what do I put? Well, I'll just put a 0, right? So a 0, right? So I'll just change this up so that it looks correct. So just 0 to 1. 0 to 1. Simple. Nothing too crazy. Okay? Now finally, last one. Okay, so we have the range must be from 0 to 1. Well, if I want a 0 to 1 for the first part, for the second one, what do I do? Well, if I want a 0, I just take it to 3, right? And if I want a 1, what do? I just take it to 4. So this is it. So this is my g of f of x for the original domain, which was based off of f of x, right? Remember, in this time, the range of f of x is the domain for g of x. This is how we can solve it. All right, now let's look at just a quick understanding or conceptual logic of domain and range of composite functions. Okay, so let's say I have, 1 goes to A, 2 maybe goes to C, 3 also goes to C, 4 goes to E, and 5 goes to D. So I'm just creating it, based on the situation or just on my whims and fancies. Okay, so let's have A going to X, B going to W, C going to Y, and D going to Z. All right, so let's say if I have, let's say my domain, okay, let's say my domain is somewhere from 1, 2, 3, 4, 5, right? 1, 2, 3, 4, and 5. Okay, so what would be my range in this? What would be my range? Well, remember, the range of my initial function, let's say I call this f of x, and this is my g of x. So the range of my f of x should be the domain of this, correct? Okay, perfect. Now, let's say I have a, C, D, and E. So the range of this is actually A, C, D, and E. That's my range. What's my domain here? A, B, C, and D. So I have A, C, and D. I don't have E, and I don't have V. So my domain for my g of x would be A, C, and D. What would that correspond to? So I have A, C, and D. That would correspond to X, that would correspond to Y, that would correspond to Z. So my range in this case would be X, Y, and Z. Again, just a conceptual understanding. I'm sure if you've been able to solve the previous questions we did, you don't really need to understand this. This should come intuitively. All right, so let's look at one more example. Okay, so we have to find the domain of f of g of x and g of f of x. Okay, so this is a reciprocal function, or you can basically call it a reciprocal function. And if you don't understand how this function is working and certain nuances of this function, I highly suggest that you take a look at my previous videos where I've, gone in depth and explained these functions. Okay, so anyways, let's start with f of g of x, okay? So f of g of x. Okay, I just have to find the domain, right? So my domain would essentially be the range of my g of x, okay? My range of my g of x. So the domain for my g of x, let's start with that. Let's start step by step. Would be all the real numbers except 0, right? Why? Because the denominator cannot be 0. So this function g of x is valid for all values of x except 0, okay? So if my zero if this is not valid for 0 and this is not valid for -1, right? So my f of g of x, let's do it like this, is valid for all real numbers except -1, right? Except -1. So now I actually have two restrictions in my function, right? One would be the domain of f of x, and one is for the domain of g of x. Okay, so if g of x cannot equal -1, right? If g of x cannot equal -1, what do I have? X minus 2 is equal to x cannot equal -1. Well, that means my x cannot be -1, right? So now my new domain of f of g of x is essentially all real numbers minus or except 0 and 1. All right, I don't know why I put -1. This is just a 1, right? So now my domain of f of g of x is all real numbers except 0 and 1. I hope that made sense. Again, I've repeated it countless times that the domain of the inside, the range of the inside function is the domain of the outside function. Okay. Similarly, let's look at the second part, g of f of x. Right. So what's my domain for f of x? R is valid for all values except -1. Right? Except -1. And my g is valid for all values except 0. Right? So same thing. I'm going to do f of x cannot equal 0. Right? If f of x cannot equal 0, what do I have? X plus 2 upon x plus 1 cannot equal 0. If I multiply both sides by x plus 1, what am I left with? X cannot equal -2. Right? So now, based on these restrictions, what's my domain? Well, all real numbers except -1 and -2. Again, super simple. I hope it just helps build the concepts that you're working on. So with this, we wrap up composite functions. Yes, questions can be complicated more. I will not deny that. Especially with trigonometry as well. They can bring in more functions, maybe sine function or sec square function, or maybe cosec functions, and just make it a little bit more hairy, right? But at the end of the day, the approach remains the same, right? Whatever we have done is applicable for any function, and we just have to make sure that that we always take the domain that's given to us, right? That is the only way these questions can be difficult. If there's no restriction on the domain, we just have to just replace f of g with f or f with g, and we can just expand the expression and then simplify it if it's necessary. Otherwise, there's not much to it. This is composite functions. Hopefully, it helps you and clears up any other confusion or doubts that you had. And yeah, that's about it. I'll see you in the next one.